Hi all, welcome and thank you so much for your time and interest. The topic today is how AWS can help with your continuous integration, continuous deployment goals, and we'll be covering it at a fairly high level. We'll start by talking about the why, the benefits to you and your organizations, and then show you how easy it is to get started with a couple of demonstrations. My name is Peter Littlefield, and today we're also quite fortunate to have my friend and fellow solution architect Alpana here to share some of her vast wisdom and knowledge around CI/CD. Welcome, Alpana.
Hey, Peter. Hi, everyone.
Before we go into CI/CD, and there are two main drivers to cover, DevOps and modern application development. The DevOps concept combines software development, hence the dev, with IT operations, hence the ops.
And at AWS, we define DevOps as the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at a high velocity. And when you have that high velocity, it enables you to evolve and improve products at a faster pace than organizations using traditional software development and infrastructure management processes. Ultimately, this speed enables organizations to better serve their customers and compete more effectively in the market.
If we take that definition and we start putting down a list of principles to help us practice DevOps in a successful way, we can see how we'd end up working towards some best practices. I won't go through all of these, but I will point out a couple in the middle. The one that says supporting agility in business and IT, and then also the drive to automate and test everything. I'm calling these two out because you'll see in a little bit how they align directly with CI/CD and modern app development. So speaking of, Alpana, perhaps you can talk to us about modern application development a bit?
Yeah, sure. So at AWS, we define modern applications as those built with a combination of modular architecture patterns, serverless operational models, and agile developer processes. This allows organizations to innovate faster while reducing risk, time to market, and total cost of ownership. So if modern applications are unique in this way, it makes sense to approach modern application development differently. And I think you'll find these approaches emphasize the practices that we should be following. You may have also noticed that there is significant overlap between the DevOps principles that we saw earlier and these approaches to modern application development. Focusing on this one approach, I think this line most strongly echoes the DevOps principle of supporting business and IT agility, as well as the drive to automate everything. And the way we can do this is by leveraging the practice of CI/CD. So let's start by defining it. Why don't you take this, Peter?
Of course, when I think about the release process, I think about 4 different stages. Those would be source, build, test, and production. Continuous integration is basically just automating the first 2 of those phases, source and build. So this means that when you put new source code into your repository, it triggers and automatically kicks off a release and completes a build. If you've only adopted continuous integration, then your test and production phases are not yet automated. In that case, you're still doing manual Q&A and manual deployments to production. And so continuous deployment, this is where you have the entire release process fully automated. What it means is that the last time a person actually touches a code change going into production, that's when they check it into the source code repository.
Let's look at the actions in each of these different phases, Peter.
Awesome, I'll go first. In the first phase, we're checking in the source, and then hopefully we're doing peer reviews, because if you're doing continuous deployment, that's the last time you're going to see that code before it goes into production.
And then in the build phase, you're compiling code, you're performing unit tests, maybe doing style checkers, creating your container images and your function deployment packages.
Test is when you're doing integration tests with other systems. You might also be doing load testing, user interface testing with tools like Selenium, or performing security tests.
And finally, you get to production. You're deploying your new code into that production environment and monitoring that code for any errors that it might have introduced into production.
So after you've adopted continuous integration, you've automated each of these steps. Well, the next question you might be asking is, what benefits are you getting from all of this? To find out the effects of CI/CD, we looked at a report called State of DevOps. They survey thousands of developers across the industry and look at what the effects are of some of the best practices and principles that we spoke about, including CI/CD. One of the first things they found was deployment frequency. So how often you deploy to production. This goes way down from weekly and monthly for teams that haven't adopted these best practices, down to hourly and daily deployments. Maybe you can talk to the next couple of effects, Alpana.
Yeah, of course. So change lead time. This is the time from when a developer checks in their source code to the time that it's actually delivered to customers. This is basically when it is in customers' hands after having gone through production. This goes from 1 to 6 months, maybe 2 to 12 releases a year. This drops all the way down to 1 to 7 days. The effect is that customers are getting bug fixes and new features written by developers and checked in under a week. The next finding is change failure rate. You might find this one a bit unintuitive. You would think that as you automate all these things, as you're doing hourly or daily deployments, you could end up breaking a lot more stuff, right? But that's not actually true. One of the great things is that as you start to deploy more and more often, you're also integrating more and more often as a team. Everything is going on to the master branch and you're effectively performing trunk-based development. So you're avoiding the sorts of problems where lots of changes start to batch up into your big monthly or biannual deployments, where it's much more likely you're going to end up with failures related to your change. So we all have bugs. But as you start to release things more frequently, as soon as the developer has checked them in, the lower the likelihood you'll encounter problems. And it's way more easy to figure out what change actually caused the problems in production. So teams on the left-hand side are shipping hundreds, if not thousands changes, which have been batching up in their source code repository for months, versus teams who are doing daily or hourly deployments, where it's maybe 1 to 3 changes per deployment. That makes it really easy to pinpoint what actually went wrong. And a great thing about this report is how it shows that these results are achievable by so many teams. Right, Peter?
Exactly. They found almost half of software teams in the industry had these results from adopting best practices like CI/CD. So this isn't some secret sauce. Anybody can adopt these practices and see these results in their organizations.
Wonderful. So we understand the benefits, but before we get to the how, let's summarize. We mentioned earlier that continuous integration spans the first 2 phases of your software release cycle. And this is the practice of checking in your code continuously and verifying each change with an automated build and test process. Continuous integration practices have made teams more productive and allow them to develop new features faster. Continuous integration requires teams to write automated tests, which, as we learned, improve the quality of the software being released and reduce the time it takes to validate that the new version of the software is good. There are different definitions of continuous integration, but the one that we hear from our customers is that CI stops at the build stage. So I'm going to use that definition.
Now, the CD, sometimes people refer to it as deployment, other times delivery. So let's cover those 2 definitions quickly. Continuous delivery extends continuous integration to include testing out to production-like stages and running verification tests against those deployments. Continuous delivery may extend all the way to a production deployment, but they have some form of manual intervention between a code check-in and when that code's available for customers to use. So continuous delivery is a big step forward over continuous integration because it allows teams to be that much more certain that their software will work in production. Then we have continuous deployment. This extends continuous delivery and is the automated release of software to customers from check-in through to production without human intervention. Many of our teams at Amazon have actually reached a stage of continuous deployment. Continuous deployment reduces the time for your customers to get value from the code your team has just written, with the teams getting faster feedback on the changes that you've made. This fast customer feedback loop allows you to iterate quickly, allowing you to deliver more valuable software to your customers quicker. And so this leads us to how you might achieve that. Now, I'm not going to go through this entire slide, so don't be super alarmed. The point of this slide is to share our broad portfolio of developer tools. Today, we are focused on CI/CD. You can see that we have tools, other tools in this portfolio to support increased monitoring and observability, for instance. We've got a broad number of SDKs, frameworks, and IDE toolkits available. If you're doing infrastructure as code deployments, which again is a good practice, we've got CloudFormation and our Cloud Development Kit to enable that. And above all else, the point here is that we provide you with the choice and flexibility. It's all about, what is right for you and your requirements and your use cases. Right, so if we jump back to our software release cycle with our phases of source, build, test, and production, I'm going to quickly map some of our services to those phases. And Alpana, hopefully you can help me explain this quickly.
Well, before you jump into that, Peter, I just wanted to ask you first. I have a number of customers that are using their own existing tools. So customers already using GitHub as their repos or using Jenkins for their builds and tests. So would they need to replace these tools with AWS tools, or how would that work exactly?
That's a good question. I'm glad you brought it up. You can certainly use your existing tools. Again, it boils down to choice. So we also offer a lot of integrations. AWS Code Pipeline, for example, allows you to integrate with GitHub or Jenkins into any stage of your release process with just one click. You can then use third-party tools for source control, build, test, or deployment. Speaking of which, Code Deploy I mentioned actually has sample templates to help you use existing recipes from products like Ansible, Chef, Puppet, and SaltStack. And so just looking at those stages quickly, we can see that Code Pipeline goes across the entire CI/CD process. And below each of those stages, you can see that there are actually a number of individual tools playing a role in each of those stages. These are the tools that we'll be demonstrating pretty soon. To cover them briefly and to give you a sense of what they do, let's just quickly look at each of those 4 stages.
And the first is the source stage. And here we have AWS Code Commit. This is a secure, highly scalable, and managed source control service that hosts your private Git repositories. This is well integrated with our other developer tools. And once again, you're welcome to continue to use your existing Git repos. It's all about what makes sense to you.
And then for our build and test stages, AWS Code Build is a fully managed service that compiles source code. It also runs tests and produces the software packages that are ready to deploy. And with AWS Code Build, you're only charged based on the number of minutes it takes to complete your build. This means you no longer have to worry about paying for idle build server capacity. And you can also bring your own build tools and programming runtimes to use with Code Build by creating customized build environments in addition to the prepackaged build tools and runtimes already supported by Code Build.
And then lastly, aligned with our send to production phase, we have AWS Code Deploy, which is a fully managed deployment service. It automates software deployments to a variety of compute services such as Amazon EC2, AWS Fargate, AWS Lambda, and also your on-prem servers. And with that, you're probably wondering how they work and what these services look like on the AWS console. So I believe you have a demonstration lined up, Peter.
I do. So thanks, Alpana. Let me switch across to the console and I will jump in and get started. Cool. So what we're going to start with is by setting up an application environment for ourselves. How do we do that? Well, one quick and easy way is by selecting this little solution here, build a web app with Elastic Beanstalk. So let's actually just click on that. It's going to be the easiest and the quickest. I'm just going to go click out of this quickly and show you that Elastic Beanstalk is basically a service for deploying web applications and services supporting a number of different languages. We can see here Java, .NET, PHP, etc. So what we can do is just click on Create Application, give it a name, demo Elastic Beanstalk app, and I'm going to choose PHP, and that's it. I have selected sample application, so it's just going to deploy a simple web app. Create application. So what I'm going to demo first is, let's say you already have some code, some applications in a GitHub repository. I am going to show you how we can get that code into this Elastic Beanstalk environment and also edit that code with Cloud9. And so let me switch across to Cloud9, Services, Developer Tools, Cloud9. So we'll open that. And Cloud9 is an IDE that we can use in the cloud. And so we don't need to install anything on our local machines. If we don't have anything installed, we can literally just go create a new environment, demo IDE, next step. It's going to create a new instance for us. I'll just leave all these defaults on, Amazon Linux 2. And you can see here that it's going to switch off this instance after 30 minutes. Well, it'll automatically hibernate it. And so while it's hibernated, we don't pay anything for that compute. I'm going to click on next step and create environment. So that's busy creating our Cloud9 environment. The little sample application I'm going to use in this demo is going to be the snake game. I've just forked it from Pratibha, who used it and developed it as part of the software engineering course at the Portland State University. It's quite old. I just thought it'd be a nice little slightly more interesting demo than simply, I don't know, editing a web page. Although it's very similar to that. You can see this actual game though. So again, very simple, index.html, snake.php, snake.css. That's all it is really. Let's see how our environments are going. Elastic Beanstalk is still deploying. And we have our Cloud9 environment. So what I'm gonna do is I'll show you a couple things here. So firstly, I mentioned Cloud9's our IDE, and we can get going with it and clone our repo into it. Just accept that. Great. So first things first, I'm just going to make sure everything's up to date. Yum update, yum -y update. Okay, it's just updated a single package there. Now we can initialize our git init. Okay, and then what we can do is just set our parameters quickly. And now I am going to quickly clone our snake game. And let's quickly look at Elastic Beanstalk is, I think, almost done. Create environment. Instance deployment completed successfully. But while that's happening, now we have our snake game. And so what we can do here, I'll just give you a little demo of us updating this on GitHub. So index.html, what's in here? I'll just change this slightly. Let's make the title Snake Game without the exclamation and some lowercase letters. We can close that, save that file, and then let's go into our folder, and then let us update this. Okay, that's done. Let's see what's happening here. Right, index.html, 23 seconds ago, it's been changed. And so we have updated our index.html. So that's us using our Cloud9 IDE. Let's see what's happening with Elastic Beanstalk. I think this is done. Let's click environments. Here we go, all environments, Elastic Beanstalk, and it gives us the URL for our application. So if I click on that, there we go. We're running, this is our Elastic Beanstalk PHP application. In the background, Elastic Beanstalk deployed that with CloudFormation, just so you're aware. So let's switch across to code pipeline, because now I'm going to show you how we set up our CI/CD pipeline. So first I'm going to show you this way, then I'm going to show you another way in a little bit, an even easier way if you're starting from scratch. But let's start with this quickly. Just want to make sure that I am still logged into everything. It looks like I am, that's fine. So let's go create pipeline. I'm going to call it, give it a pipeline name. So let's say demo snake pipeline. I'll let it create a new service role. That's fine. We go next. Source. I mentioned that these developer tools, have lots of integrations with third parties, and you can see right here, we can integrate with Bitbucket, GitHub Enterprise Server. So we've got a bunch of options here. I'm going to say GitHub version 2. I need to connect to GitHub. So let me click on that. We'll give it a connection name, GitHub connection. Connect to GitHub. Peter Littlefield, that's me. Connect. And now I can choose my snake game. Master branch. Code pipeline default, go next. Now, if this were production, obviously I'd want to build, especially if it's a complex app. In this case, it really is just a few individual files. There's nothing really to build. And in the interest of time, we're not going to do any testing. We could also do testing with code build. So I'm just going to say skip build stage, but you can see we can choose code build or Jenkins. I'll show you how those work in a moment using that second method I touched on. So let's go skip build stage for now. And our deploy provider, again, I might use code deploy if this environment were a bit different, but given that I've got Elastic Beanstalk running my application already, I'm going to click Elastic Beanstalk. It's picked up my demo Elastic Beanstalk app. And so it auto populates that. I just go next and create pipeline. And it is as simple as that. What it should do now is, without me doing anything further, it's going to take our snake repo and it's going to deploy that to our Elastic Beanstalk environment. So let's watch here for a second. We can see it's picked up the source of our GitHub environment, and it's going to deploy through Elastic Beanstalk. We can see now succeeded. Elastic Beanstalk in progress to deploy that. While it's doing that, I'll show you something on Cloud9 quickly. So not only is Cloud9 quite nice in terms of just being able to get up and running with your IDE, there's a lot of support in it. So if we click on Run to run our code, we can see that there's a lot of options here in terms of libraries we can use. What else can I show you? Well, one of the really nice things is if we click on AWS on the left here, we can click on the drop down and we can access services in AWS directly. So if I click on that, it'll build out what S3 buckets I have here. It would build out any Lambda functions I have running. It'll show me CloudFormation, so we can see Cloud9 actually uses a CloudFormation template to deploy this instance, and that's our Elastic Beanstalk template to deploy the app I just showed you. And we can access any API gateways we might have deployed. So it's a nice, easy way of directly accessing AWS services. Let's go back to our pipeline. And it has done. I should have just hit refresh there. So let's go back to our Elastic Beanstalk application, shall we? Let's pick. So earlier on, it just showed us a very simple sample app. I don't know if you remember that. If we open it now, we've got our snake game, fast, simultaneously calls to play. So that's our snake game. So one extra little thing I can show you is, so I don't know about you, but I'm not super happy with this bright green color for the background. So let's look up CSS colors. Maybe something a bit more neutral, like this Alice blue. I kind of like this Alice, or yeah, definitely Alice blue. And let us go to code. Let's go to our IDE. So in our IDE, what's here? Let's look at snake.css. I think that's where our background is. Okay, there, background color. So let's take that away. Let's put in our Alice color and close that, save that. And then let's just update this. Well, I didn't actually change the title, but we'll leave that as the comment. Right, so we've pushed our update with the different backgrounds. So let's see what code deploy is doing. Okay, so code deploy just picked up the change to the source. And I think it will be busy deploying. Oh, there we go. Succeeded just now, and it's busy deploying that change. And it succeeded, so let's go back to our snake game, refresh. Ah, that's much better. Not quite as garish. Fantastic. So that is our pipeline. So basically what's happening is in Cloud9, we are making changes to our application. We're pushing that change to GitHub. GitHub is triggering code pipeline to recognize that there's a change to our source, and then that is deploying it through Elastic Beanstalk. So I thought that was pretty cool, but I'm going to show you a slightly different way of doing all of this now. So let us go to a service called CodeStar. So I mentioned Elastic Beanstalk is there to deploy your web applications, right? CodeStar is a little different in that it does that and a whole lot more, and not only on EC2 as well. You can see here it says quickly develop, build, and deploy applications on AWS, but it does that and it enables you by providing one single interface kind of across all your development activities, and it sets up the entire chain in one shot. And it gives you a bunch of other options in terms of how to deploy your applications. So you can even deploy them serverless. I'll show you how that works now. We'll click on Create Project. Already you can see that it's a bit different because we've got Lambda here. We have got EC2. Let's just create the service role first. What I'm going to do is change this to 24 templates, just so I can show you a broader spread. So we can deploy Go, Node.js, Python, and like I said, we can deploy them across EC2, across Elastic Beanstalk, into Elastic Beanstalk. We can deploy them Lambda serverless. I'm just going to pick EC2 for now, so it's a bit different to the previous deployment which we picked, which was Elastic Beanstalk. So let's just go straight EC2. I'm going to pick PHP Laravel. Next, we just need to give it a name. So demo code star PHP. Here it gives us an opportunity to select different repo provider. I'm going to just go with code commit. It's going to set that up automatically for us. EC2, I'm just going to leave it as the T2. I'm going to leave it on my default VPC. I'm going to pick a random subnet, subnet 2, and use my existing key pair. That's fine. Next, create project. It is as simple as that. It's now going to go ahead and set up everything for us. What I'm going to do, so as not to waste anyone's time, is fast forward through this. But I think before I do that, I just want to show you a couple things very quickly. So you might be wondering, what the cost of some of these services are. I'm going to show you quickly that there is an easy way to find out what AWS services cost. In fact, there are two ways. So AWS pricing calculator. Just go to calculator.aws and you can develop service estimates here across a whole number of different AWS services. I just wanted to kind of share that view because this is something you can go and look at yourself and use to price broader solutions. But not only that, if you just go to aws.amazon.com and go / for example, CodeStar, which is the service we're using now, and go / pricing, that's typically how you find your pricing for most AWS services, is you literally just go aws.amazon.com / service name / pricing, and you'll get to a pricing page. Now, with CodeStar, you can see there's no additional charge to use CodeStar itself. You only pay for the resources that it effectively deploys as part of your project. As I showed you a moment ago, I'm deploying a project using an EC2 instance. And so in that regard, I'll end up paying for that EC2 pricing. Same thing goes for the other supporting services. And some of the services we've spoken about today are Code Build, Code Pipeline, and Code Commit, along with Cloud9. So I'm just going to give you the briefest of views of these quickly. We'll go through each of these. I just want to show you that, these are pretty cost effective. So firstly, Cloud9, you're effectively only paying for the duration of your IDE. And it gives you some estimates here of if you use the default settings running an IDE for 4 hours per day for 20 days in a month with a 30-minute auto hibernation, it works out to about $2 over that month. So you can see it really is quite cost effective. It does, however, depend on the instance type that you take in Cloud9. If we jump across to code build, this is now where you want to build out your application and maybe do some testing. Code build, you literally only pay for the duration of the compute for however long it takes to build that application out. So if it takes 2 minutes to build your application, you only pay for 2 minutes of compute. Again, it tells you what the pricing is here for the service and then gives you a pricing example. So if you execute 100 builds in a month using a general one small, and each build runs for 5 minutes, again, that works out to $2 for that monthly build charge. I think you'll agree that's a lot more palatable than needing to have a server always on and always available for builds, even if you're not using it. Code commit, first 5 active users, 0 charge. You get unlimited repositories, storage, and a number of Git requests per month. And then you can see the additional users are $1 per month for each active user. Code pipeline, again, no upfront fees or commitments. It's just $1 per active pipeline, and pipelines are free for the first 30 days after you create them. So that gives you, I think, a great opportunity to kind of play and experiment with them. So just wanted to kind of give you that view while we were waiting for CodeStar to build everything out for us. Okay, it's saying project provisioned. This is still showing as in progress though, so we'll give it a moment or two more. While we wait for this, also just wanted to show you, not only does this build out a full pipeline for you and connect a whole bunch of AWS services to your project, but you can also set up additional users as part of your development team here. So we can go create user profile. Well, that's for me, but we can add additional users. If we go into the project, we can go into issues, and you can connect this to Jira if you like. Under monitoring, okay, we're not seeing the monitoring because it hasn't been fully deployed yet. But yeah, just wanted to kind of give you that extra little view in terms of users. It also shows you if you're going to edit and work with the application on your local computer, then it gives you some instructions to do that. But as you'll see in a moment, you don't need to do that. You can just, again, use Cloud9, and I'll show you how it's even cooler with this CodeStar example in a moment. Cool. So our project has been deployed. At the top here, we can go view application. So let's click on that. And we've created our PHP Laravel web app. So it really was as simple as that. What I'm going to do now is, you can see here we can develop with Cloud9 or we can develop with other IDEs. They also have integrations with those other IDEs. I'm going to go set up Cloud9 though. I'm going to call it CodeStar IDE and create environment. And it says here CodeStar IDE has been created. So it is busy with that. Going back to team, you can see I have added my details in here, and we can go add team member. And under the user settings, we can either pick an existing IAM user, or we can create a new IAM user in the IAM Identity and Access Management section of the console if we like. I'm just going to cancel out of that. And then you can put in the relevant details, display name, email address. So you can add team members to the project is all I wanted to show you there. If we go back to our project, we can go to the repository. And so we can open that up. I'm just going to go open new tab. And now it's opened it in code commit. So this is effectively what you might use on AWS instead of using GitHub. So we can do a couple things. We can actually edit in here directly. Not the easiest or quickest, but I can give you a demonstration quickly. So if we go to resources, views, welcome blade. So here is our front page. You've just created a PHP Laravel web app. In fact, I'm just going to give it a moment because I'd rather us have our IDE deployed and use that, because I don't want to create a conflict where it is busy effectively linking my repo to Cloud9 and then I start changing code commit before it's deployed that. I don't want to break anything during the deployment process of Cloud9. If we go back to Cloud9 here, I'm just going to close that. If I search for Cloud9, what we'll see is we'll have the previous Cloud9 environment that I created earlier. So that was the demo IDE I created at the beginning, and here's our CodeStar IDE. Open IDE. So this is the IDE, it's already deployed. I think it's just taking a moment to update on the CodeStar page. Oh, it was there, in fact, Open IDE. I was clicking on the wrong thing. And so the neat thing you'll notice is that I didn't have to go in here and then set up Git and then do a Git clone. I didn't have to do anything. I literally just asked CodeStar to deploy Cloud9 for me, and it set up Cloud9 with the repo cloned. So we can go to what I was speaking about just now. We can go to resources, views, welcome blade, PHP, and we can go here. And then straight from here, we can go and change our content. So let's just check out the web page. So congratulations, you've just created a PHP Laravel web app. Let's go back to our IDE. Where does it say that? I don't want to take all the credit, so I'm going to say we have just created a Laravel PHP web app. Put an exclamation there, and then go, isn't it citing? And then let me close, save. I'm just going to go get, see, get add. Ooh. Now, a couple things. If we go back to our repository, so that's what we edited now. And if we look at CodeStar and look at our pipeline, remember, we just created a project. We didn't do anything more than that. CodeStar has set all of this up for us. So CodeStar just picked up our change in code commit, where we changed this. I'm just going to hit refresh. I don't think it's set it up just yet. Yeah, so we've done that, and it's basically sending it to code build now to build our app. It's going to generate a change and it's going to deploy it. Succeeded 1 minute ago. It's doing the package, it's exporting it. As soon as it finishes exporting that, it's going to send it for deployment. So that's quite literally our entire CI/CD pipeline that's been set up. And as you can see, all it took was for me to go and type in git push, and that's now sent it all the way through to this process. We can see it's generating a change set. We can click into these for the details if we want. There it's updating that infrastructure. Executing change set. Code deploys in progress. And it's succeeded. So if we go back to the web page, refresh, we have just created a PHP Laravel web application. Isn't it exciting? And so I hope that just gives you a sense, firstly, of how you can still use GitHub, you can still use your own IDEs, and you can see how you can still use Code Pipeline to create a pipeline in AWS. Or if you're starting off and it might make more sense just to leverage these tools, which already, as you can see, are super integrated into one another, and are especially well orchestrated through CodeStar, that this is an equally valid option. And so, like we always say, it's all about choice for you. But I think in terms of offering that kind of enablement to get innovation, to get features out quickly, to get value to your customers quickly, and to make your environments just easier to manage, maintain, and deliver these sorts of features, that CI/CD code pipelines, it really isn't hard, and it is quite cost effective and really, really easy to deploy. As you can see here, we've set up an entire pipeline, and this combined with our previous demo, it's been really quick. We're well under an hour here in terms of setting up this pipeline. And so, yeah, I hope that piques your interest and gives you some sense of how to get started with CI/CD and the value it brings. So I hope you enjoyed that demo. That brings us to a close. I hope this gives you a taste of the value and benefits you can derive from our developer tools portfolio and supporting offerings and how they practically work in kind of a real world example. As always, we'll spend a few more minutes online to answer any questions you may have. And I hope you have a great rest of the day. Bye-bye for now.
Thank you. Bye.